All right, guys, welcome back to another video in the college algebra series. Today's video is going to be dealing with finding the domain of a function. When you're dealing with domain and that question of finding the domain, you're really looking for what x values in your equation can you put into your equation, right? This leads into like finding holes and finding, vertical asymptotes and stuff like that, which are for later videos that I'll get into. But the domain deals with the x values, and then in later videos we'll get into range, which is your y's. What y values do you get out? So, but like I said, domain is what is domain? The domain is the x values. That's values. That's a terrible writing of that. Values that you can use in an equation. Okay, now depending on what the equation is, kind of determines how to easily find that domain. There's both ways, both graphically and algebraically, and just kind of depending on the equation, kind of determines which method is the easiest. And so I'll kind of show you both, and I'll kind of show what it would look like on a graphing calculator, and then what it would look like how to do it algebraically. And so you can kind of start to see kind of how to choose which method works best and which is the easiest to understand. Right, so our first question is how to find the domain of a function, or what is the domain of the function. And so our equation is f of x, or y, equals the square root of 9 minus x squared. And so I'm going to solve this graphically, meaning I'm going to use a graphing calculator to show you kind of what it looks like and what you're looking for. Right, so let me jump over to a graphing calculator real quick. And let me clear that. So it's 9 minus, so y equals the square root of 9 minus x squared, right? And so if you look at this, right, your graph is half of a circle, right? And so the lowest x value that you can use in this equation would be -3, and then as you travel along this curve, the highest x value that you can use is +3, right? If you use even 3.01 or -3.01, you would, get an error. The point does not lie on the line, thus it's not a solution, right? So graphically, just by looking at this, I know my domain has to be between -3 and 3. And so how you would write that in this, you would say your domain. So a lot of times it's denoted by D, right? So you'd write your lowest x value, right? Because domain only deals with x's, is less than or equal to x, which is less than or equal to your highest value, which was 3, and that would be your domain, right? Now, if you look at this one, f of x, or y equals x squared, let's jump back over to my equation, and so we go y equals x squared. So if you look at this, there, you're reading a graph from left to right. If you kind of look at your graph, it goes and it keeps getting bigger and bigger in both directions, right? There's no stop and no start to this graph. And so your domain, you can pretty much use any value of x, both positive or negative, right? And so if you wrote this graphically, you would write it as all real numbers. So all real numbers. Okay, now there is other ways of writing this instead of with a compound inequality or the expression all real numbers, and we'll get into that in another video. But for today, this is how you're going to see it in the beginnings of chapter 1 in college algebra. right? Now, algebraically, how you would solve this, so again, we have the f of x equals the square root of 9 minus x squared, right? You kind of have to know that, we're not dealing with imaginary numbers and, square roots of negative numbers. That's bad, right? So basically, what's underneath the square root has to be at least 0. And so, you can basically say 9 minus x squared is greater than or equal to 0. And then you start solving, right? And so if you move x squared over, so I'm going to add x squared. So I'm going to add x squared to both sides. I get 9 is greater than or equal to x squared. And now I'm going to square root. And when you square root, remember when you square root, you always get two answers. You get the positive and negative number. So you have the plus and minus, plus and minus 3 is equal to x, right? And so basically, there's your x is greater than or equal, is less than positive 3 or greater than negative 3, right? So you could write this out as negative 3. My gosh, my pen's not wanting to write tonight. Is less than or equal to x, which is less than x, which is less than or equal to 3. So it's kind of weird. It's kind of wanky, especially with this. It's just not, if you get a square root, I would suggest using a graphing calculator. It's much easier to see than, working it out algebraically. Now, the second equation, you have f of x equals 1 over x minus, or x plus 2. This is one, you can graphically. If you do, you would see something like this. So let's come back in here. Let's delete that. So we could say y equals 1 divided by x plus 2, right? And if we look at our graph, right, we get what's known as a vertical asymptote at x equals 2, right? And so that means you can't use, basically your graph is going to get really, 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 really close to the line y equals or x equals negative 2, but it will never, ever, ever cross. If you scroll in, see how it's getting closer and closer and closer, but it's never crossing. That's what's known as the vertical asymptote, and that's for later in the chapter. We'll get into finding those and how to find those. But this is a type of problem that I would suggest solving algebraically. It's really, really easy. So you have y equals 1 over x plus 2. How do you solve this algebraically is, and how you find the domain, especially when you have what's called a rational expression, because it's a fraction, is you basically, you can't have 0 in the denominator of a fraction. So basically you just set the bottom of the fraction equal to 0. So you say x plus 2 equals 0. Right? Well, if you're solving for x, you subtract 2 from both sides, you get x equals negative 2. So your domain is what would be considered all real. That's not how you spell real. It's an extra real numbers except x cannot equal negative 2. Okay? And that's how you'd see it in the beginning stages. Now there's other ways of writing it, with little u's and brackets and parentheses and stuff like that, and we'll get into that in another video. But you can see that, again, you can see that from your thing. You can see, you can use any of these negative numbers all the way up until you get to x is getting closer and closer to negative 2. And then once you come to negative 1.99999, and then any positive number, it'll fall along your blue lines, right? So that it falls on your line, it's a solution, right? And so that's how you find domain of a function, both graphically and algebraically. Like I said, if you're given a rational expression, solving it algebraically is maybe a little bit easier to see. If you're given something with a square root, or just an equation or something, plugging into the graphing calculator and seeing where there's holes or where graphs begin and end might be a little bit easier to see. So it takes a little bit of practice, but with a little bit of practice, you can find these types of questions pretty easy. If you have any questions, please don't hesitate to ask in the comments below, or in my email in the description. You can send me an email and I'll be glad to help. Thanks.